A particle P moves in a straight line with position vector relative to O, given by S of t is t cubed minus 5t squared plus 2t plus 8 meters, and this applies for t greater than or equal to 0. Find expressions for the particle's velocity and acceleration and draw sign diagrams for each of them. So v is going to be, just differentiate this one, and we get 3t squared minus 10t plus 2. And then the acceleration would be 6t minus 10. So if we consider the velocity to do a sign diagram, so starting at 0, we need the times when the velocity is 0. Now I've used technology to do this because this one is not a quadratic that solves easily. So the values where it changed were 0.214 and 3.120, and these are both given to 3 decimal places. Now initially we can see when t is 0 the velocity would be 2, so it would be travelling in a positive direction here, then it's going to be a negative direction here, and then it will be positive again here. If we do a sign diagram for the acceleration, we can see for the acceleration to be 0, we'd need 6t equal to 10. So t would be equal to 10 over 6, or 5 on 3. So 5 over 3. And we can see initially when t is 0, that it will be negative 10. So it will have negative acceleration and then positive acceleration after this. So we're now asked to describe the motion at t equals 0. Well, we can see it's got a positive velocity and a negative acceleration. So it is moving in a positive direction and slowing down. Slowing down because the movement is that way, but the acceleration is that way. Find the position of the particle any time where it changes direction. Well, the change of directions are here and here, and so we need to do S of 0.214 and S of 3.120, and that's just a case of substituting those values into our formula here. So those values are 8.209 and negative 4.061. We now want to draw a motion diagram for the particle. So we're going to need a number line for that. And I'll start at negative 5. And we need to go as far as 8. Like so. Goes a bit beyond 8. All right, so we start with S of 0, and that is at 8. So we'll start there when t equals 0. Now it only goes up a little bit before it turns around, because it only goes up as far as there. So that is going to then arc around, come all the way back to there, which is this value, and then it will turn and it will go back this way. So we can say that this is at t equals 0.214, and we know that that distance was 8.209, and I've gone a bit too far with that one. I might adjust my number line. So negative 4.061, that happens at t equals 3.120, and then the particle turns and keeps going back. So that is our motion diagram. Find the total distance travelled in the first 10 seconds. Well, we know that it started off with a motion where it went 0.214 that way, it then went back quite a long way that way, and then we want to know how far it's gone when t equals 10. So the distance it travels back is going from there to there. And so that would be going on the diagram all the way from there across to there. And therefore we can get that by doing 8.209 plus 4.061. So that distance is 12.27. We then need the S of 10 figure. And that is 528. So it's therefore gone from negative 4.061 up to 528, which is 532.061. So our total distance travelled is 0.214, add 12.27, add 532.06, giving us 544.54 meters. Of course, we should be able to do that with an integral of the modulus of the velocity between 0 and 10 on the calculator.